Welcome to a special edition of the Data Exchange podcast. And we have our guest host, Jenn Webb, who will chat with me and Jesse Anderson about Jesse's new book. So take it away, Jenn.
Thank you, Ben, and thank you for joining us today, Jesse.
Thanks for having me.
So, just jumping right into your book, of all the topics in data, why did you choose to write a book about teams?
I wrote a book about teams because I saw that it was the initial success or failure. A lot of the books were either raw data science, which is fine, or they were, here's what you get after years and years of data science, but there was nothing that said, now how do you do it? How do you set up the team? How do you make sure that the teams are successful? I would also say one of the things I'm most proud of in there is really putting the forefront and the focus on, yes, you have the three teams, but how do those three teams work with the business? I've worked with companies where they did have the data teams, but there was this estrangement and this lack of relationship with the business. And now, yes, you're creating stuff, but nobody uses it.
Right. And so what's the structure? Like, what is a data? Like, how do you set up a data team? Who's on a data team?
I say that in the book that there's three teams within the data teams. There's the data science team, the data engineering team, and the operations team. And the data science is definitely the one that you're thinking of. It's a group of data scientists all on a team. The data engineers, that one may be different for people because data engineering or data engineers can mean different things at different companies. At some companies, it means a very SQL-focused person. For example, they're doing ELT, ETL. They have their SQL developers as their title, or they're in data warehousing. And that isn't the team that I'm talking about. I'm talking about data engineers being software engineers who specialize their skills in big data. And this is a different issue altogether. This is one of the issues that companies are having where they're thinking, okay, I have all these data warehouse people. I'll just have them be the data engineers creating these data products for data scientists. That just doesn't work. The skills are too separate. So that's another core part. And then we have our operations people, where operations people are sometimes missing in companies where we create these data products and they're not available all the time, or they're not well running. There's no operational excellence. And as a direct result, whenever the business goes to use them in whatever fashion the business needs, they have a lack of the lack of belief that the algorithm is going to be running, that the data product is going to be available. So we need to make sure we have all three of these teams. And one thing I like to point out is sometimes people will say, well, what's the only one I need, or what's the most important one? And the reality is that all three of them are equally important. They all bring a certain part to that value creation. The data scientists in many ways are creating that cherry on top. They're creating that last mile. It's crucial, important last mile to have that advanced analytics, but it's that last mile sits on top of the data engineering that the data engineers have done, the infrastructure that they've done, the data products that they've created, and that is complemented by the operations team making sure all of that runs.
And Ben, what's your experience? You've been working on data teams for a long time.
So as I was listening to Jesse, I was struck by his description of what he covers in the book. So as I understand it now, Jesse, you're concerned about, literally the data team, right? So you're not making the claim that the data team is all you need. Because in my experience, obviously, you need all of the pieces that Jesse described, but you also need people on the business side, maybe on the compliance side of things, product designers. But so as I understand what Jesse's describing, these are the people responsible for the data component of whatever it is that the people are building. It might be a recommendation engine, a forecasting tool, but I think it should be clear to our listeners that you need more than these technical people.
Yes. Yeah, you definitely need. In fact, I have entire chapters just dedicated to saying, here's what you have to do with the business. One of the ways I like to visualize this, if you know the Sistine Chapel and you know that picture of God touching Adam, this is the visualization you should have with your data teams in your business. They should be touching each other in the ways that your HR department allows. So they should be touching each other metaphorically rather than they don't talk to each other, or they talk to her through these stream of intermediaries. The other thing I'd really strongly point out is sometimes the business side thinks that they come up with a data strategy and then walk away. And that's another crucial part that I've seen where no, the business can't walk away after the data strategy. They need to be continually working with the team. This could go so far as to attending scrums, the daily stand-ups, as it were. So yes, you do need those other people. You need the project managers, you need the program managers, you need these other people. And only then do you create this usable data product for the business, for the rest of the company.
Right. That sounds like it feeds into one of the things that you've said is that most companies fail at big data projects. And that sounds like it feeds into the reason why that happens is that you're missing either links between teams or you're missing entire teams to get the project done.
It's definitely one thing I like to tell people is I can walk into a company and I can tell them which team they're missing just by either talking to the business or talking to the other teams. Usually what I actually personally do and I recommend in the book is I say, go talk to your business and ask them this question. Let's say I were to completely cancel your recommendation engine, your forecasting engine project. What would the business say? And depending on what they say is this reflection of not just how successful you were, but what structure, what organization is missing or what pieces are missing. And if they say, what project? That means that you never got it off the ground. Or if they're saying, I can't use it, go ahead and cancel it. That means we were missing operations. Or if they're saying, I've never heard of advanced analytics, recommendations, forecasting, it means you're missing your data science team. Or if they say, I go to try to use it, but it just in the middle of the day, it fails. It can never handle the load. Probably missing your data engineering team. So what I talk to people about is that link between your data teams and your business. You go so far as to ask them. You go so far as to talk to them. How is this useful? Are you able to use this? Is this meeting your needs? And this shouldn't be at the very end. You throw something over the fence and say, all right, here's your forecasting engine. This should have been an iterative thing where they should have been seeing this data product, this product all along.
Right.
Jenn, there is also something that is accompanying the things that Jesse's pointing out, which is, I think, and I don't want to oversell this, but there is also improvement in the tools that people use. So, which means that things that certain specialists that were confined to certain specialists can be done by more people now. So, for example, in data integration and ETL, I think we're beginning again to see another generation of tools that are opening up the creation of pipelines to a slightly wider population, not just people who can code in Scala or Python or even SQL.
Or Java.
Yeah, or Java. Yeah. Do you agree with that, Jesse? That I mean, I think so. There's a danger in overselling these tools as being a replacement to the specialists, but it does free up the specialists to do more and have the generalists tackle some of the more low hanging fruit, right?
It can be. You can have some of those tools, and what those tools can get you is some of that low hanging fruit. But I think it's important for management to understand what low hanging fruit means and to really look at their use case and establish what is low hanging fruit versus what you're going to have to do for the generalists or for your data engineers. So do look at that. Do do have a clearer idea of what can be done, what cannot be done. Otherwise, you'll throw people, your ETL, your ELT engineers, at something that they can't do, or that they'll do it and it will be so tech debt laden that you're back to square one. You're going to have to go back and fix that. So do think about those tools, think about the people. It's really important to have I talk about this in the book as well, a real honest look at your team. You may have hired them, they may be your friends, for example, but it's really important to take an honest look at those technical abilities relative to what they're trying to do. And otherwise you will have some major problems, whether those are using a tool or not. One thing I'll also point out on tools is sometimes the tool isn't the issue. Either the programming or lack of programming, sometimes that isn't the issue. Sometimes it's the sheer difficulty of systems creation, where the person who's trying to use those GUI tools simply does not understand well enough the rest of the technologies. They can move some data around, but to create that full data product, it's outside their ability.
So how much training do you usually see is necessary when you're trying to set up like a new data team?
Specifically around starting with the data engineers, this is something I talk about in the book as well. Sometimes companies will think you just throw them in a weekend, and in a weekend they can do this, or in a week. My experience, you're taking 1 to 6 months as a data engineer to become comfortable with these tools. And this is important for management to know, because I've rarely seen a Gantt chart actually say, here's the team ramping up on this, or that although we're starting and we're working, our velocity is much lower. So it's really crucial that you as management look back, see, do we have a time for people to skill up, and are we going through that, and are we appreciating that in our project timelines? So there's that initial data product creation that then flows into the data science creation. Data science aside, if you're training, let's say, a data analyst, and you're trying to make them data scientists, for example, I've seen that take anywhere from a month to a year, depending on the people, depending on complexity. Your operations team, that can take anywhere from 1 to 3 months. Usually what the core issue for operations people is more of experiential and more knowledge. And you quite honestly can't teach experience all the time. In whatever case, whatever starting point your team is, what you want to do is you want to take an honest look at their starting point. Let's say your data engineers are software engineers that you're moving over. That's an easier path. And in fact, I have a post coming up where I kind of visualize this out and say, what does a technology tree look like for when you're starting from a data scientist or from a software engineer? They have good programming, but they're missing the technologies. They're missing the technologies behind the scenes. And this is part of what makes data engineering so difficult. With data engineering, we are using 10 to 30 different technologies, which is quite a few. This is far more than what you've had to do as a software engineer for most of your career. So it's varying degrees of knowledge of those technologies, but it is still a sheer number of technologies that you're having to deal with. In a similar fashion, your operations team will have to support lots of different technologies. What you ideally want is that difficulty, that level of complexity isn't then pushed upwards to your data scientists. What you ideally want to do is to make that as either not as imperceptible as possible, as easy as possible, or in some cases, some companies actually handle the distribution out for them, that the data scientists write to an API where they're not thinking about distributed systems concepts or complexity.
Ben?
So I think my reaction to what Jesse said is that one, maybe you should hire the right people, so you don't have to train them for 6 months. And then secondly, I guess I'm kind of have this kind of Silicon Valley perspective that's not realistic, in the sense that how come the company that the average company, as Jesse describes, are using so many tools? Why can't they consolidate to fewer tools? Well, but the reality is that in a lot of companies, they are using a lot of tools because over time, different teams just start using tools, and there's no centralization of decision making around tools, and you end up with a lot dependencies and many different systems. So data is coming from many different systems. There's just not much you can do about that. But I think that at this stage, I would say that there are some core tools that a data engineer needs to know, and the people who know how to use these tools exist, but they're fewer than what's needed by the market. So I think Jesse is correct that you should probably plan to uh, make sure that you can upscale and train your people accordingly.
I want to
One
get
thing I
back
talk
to.
about, so I wanted to
Go
follow up
ahead.
on some of the things Ben said. I talk about that in the book of the trade-off. So there's a trade-off here of hiring from without or from outside the company versus training inside. So that answer I gave you was an internal training. I'm going to take existing people. So the basic calculus you do there is you try to figure out, is my domain knowledge so difficult that it would take me longer for them to come up to speed on domain versus training them on this. In the book, I give the example of healthcare. Usually healthcare is my touchstone for highest domain knowledge, most difficult to understand. So if I was running a healthcare company, I would probably be saying, oh man, it's going to take forever for them to come up to and understand all this, whatever these medical codes are and all of this domain background. Maybe what I'll do is it will be easier for one of my internal team to learn this. Whereas if you're coming from, let's say, a social media company, not a hell of a lot of domain there. What I'd probably be looking at is, I can hire somebody, I can show them how our systems work, and that's a different story. Ben also brought up another thing of interesting part of difference between San Francisco Bay Area and the rest of the world. And I think this is an important distinction that management should take into account. If you are watching a conference or you're listening to a podcast and that person is from San Francisco, they have a different set of skills, talents, access to people than even the rest of the US or the rest of the world. And this is something I've really tried to look at as I've worked with companies around the world and around the US, is what their difference in skill levels are, difference in talent pools. So if you have the ability, definitely hire remotely. You will open up your talent pool significantly. In one of the interviews, I asked that question to one of the interviewees: is the San Francisco Bay Area different? And it definitely is. In his opinion, and my opinion as well, you will have a difference in terms of instead of having somebody with maybe 1 year of experience, and you're lucky to get that, you could find somebody who worked at technology company X, and if I pay them enough money, they will join me and have 10 years of experience, let's say. It's a big difference.
So from a practical standpoint, like, what are the first steps to setting up a team? And does it require, so you've got engineers and data scientists and business people. Does it require you to hire a new position that's sort of a go-between moderator or communications central or something like that?
I actually have a chapter in the book just about how to start up teams, a data team. And what I recommend is starting with the question of, do I have a big data problem? Do I have a data problem? And that's really core. This, for management who's watching this, if you don't have a big data problem, don't shoot yourself in the foot this way, please. This is not a specsmanship. This is not saying I have big data. This isn't a great time to pad your resume. It's fraught with so much failure. So please don't do that. So really establish that core important need for big data products like this. And then out of that, we start to look at it and say, we start to hire a data engineer, in my opinion. So there's two schools of thought of who your first hire is after this. So you've established this business case, you've established this need. So do you start with a data engineer or do you start with a data scientist? In my opinion, you start with a data engineer because they're going to start creating the data products so that once you start hiring a data scientist, they're not sitting there twiddling their thumbs. And I've seen this very, very often where the misunderstanding from management is that data scientists can do data engineering. And some can, very few can. I want to be clear, very few can. But so what will happen is that one of two things will happen with those data scientists, in my experience. They'll either sit there twiddling their thumb saying, why didn't you give me a data engineer? And they'll quit. Or they'll start creating these systems, but they're tech debt laden systems. They're kept together with duct tape and love and hope. And so what will happen is they'll create these systems, and then a data engineer will inevitably have to go back and recreate those systems better. So the reason I recommend starting with that data engineer is they create those systems, they create ideally non-tech debt laden or tech debt that's known. And then once you establish these, you create these data products, then you start hiring those data scientists who are right out of the gate productive because they're able to leverage those data products that a data engineer has already started with.
Ben, what's your experience with the setting up data teams?
Yeah, I think I agree. So I think that while most articles and the media writes a lot about data scientists, but the reality, I think, as most insiders know, is that you need more data engineers than you need data scientists, number one. Number two, there's actually more automation happening on the things that data scientists are traditionally identified with, like, for example, building models. So there's now things that automate some of those things than what data engineers do. So, because I think, for example, you take data pipelines. They're widely known to be complex, hard to maintain, hard to deploy, hard to update, and there's not a lot of great tools yet in those areas. So you still need a lot of people who are skilled to do them. Now, on the other hand, it's true that even the data scientists will tell you that modeling is such a small part of what they do that 90% of the time they're fixing data. They're getting their data ready or fixing data problems that result in their models not producing the desired results. So that part of what the data scientist does is still, I think the tools are still not as advanced. So there's still a lot of tools around data quality, data cleaning that need to be built before you can say that you need fewer data scientists. But with that said, I don't know what Jesse feels, but I think that a competent data engineer can get you to that first model adequately. And you might not even need a data scientist for a while until you actually establish the business case and the real need to really refine and go beyond that first simpler model.
I've only experienced that or seen that at one company, and there was one company I really want to dig into it because it's the first time I'd seen software engineers actually creating a model, because I think that this is our future state. Our future state is exactly what you said of in software engineers, we've often dealt with things that are more complicated that we don't understand. I think a great example of this are audio and software video codecs. We don't need to understand the video codec. We just need to understand the programmatic interface of here are the trade-offs of this codec. And I'm wondering if data science will become very similar of we will have general knowledge about these models and here you can apply this, but if you had a better person, a data scientist, they would be able to do that. But in answer to what you were saying of your data engineer getting your first model out, I haven't really seen that. Only seen that at one company.
Yeah, startups do it a lot.
Oh, they do.
Well, because they have fewer people in the beginning, right?
Yeah.
So yeah.
And you also point out some of these auto MLs.
Yeah.
I mean, I think another good example of this is text to speech or speech to text, for example. You've got
Too, too
Google's.
too complicated for even a regular scientist to tackle. There's too many moving parts in the speech system. Actually, a speech system traditionally is comprised of several models, not just one. Um, but with that said, Jen, I don't want to oversell automation either. You still need data scientists to help you understand whether or not your model is misbehaving, uh, or tune a model for your specific domain, because a lot of these out of the box models are trained on general data, not necessarily for the data that you're concerned with in your domain. I guess my premise is that you probably need less of them, more of the data engineers.
Right. So we've talked a little bit about the challenges of the tools and technologies involved. Jesse, are there any specific tools or technologies that actually facilitate a working data team?
So one thing that I stress in my book and in consulting as well is we don't talk about technologies till we understand the business case. Mm-hmm. So with that said, when we're looking at tools, when we're looking at technologies, we establish clear business case, clearly what the business wants to do, and then we choose technologies. This usually happens the other way around at most companies. And what happens is it's either a decision based on what's popular or what conference they went to or what they want to put on their resume, quite frankly. So really key management, if you are, as you're listening to this, make sure that you do this the right way. Otherwise, you will choose the wrong technologies for the job. With that said, some of these technologies are actually facilitating much easier adoption. But one really key thing to know is that we need some foundation before we start adding in new technologies. So making it easy to be able to add new technologies, add new data stores. Kind of coming back to a point that Ben made is why do we have so many out there, so many of these technologies out there, is that usually they're optimizing a use case where we may have a general use case and we may just be storing data in S3 or its equivalent. But that may not be fast enough for our business intelligence or to power a dashboard. And so we're going to stand up Druid in order to power that dashboard, for example. Now, that ability to stand up a new technology, that really shows how well we exposed our data products. Of if we're having to rewrite completely new things and we're really having to do some brand new pipes, that probably means our data pipelines weren't done effectively. But if we're able to use our existing data pipelines, use them, then we know we've stood up those technologies well. So those foundational technologies, kind of to your point, what helps the data engineering team prevent toil? It's having a solid foundation, solid data pipelines that we can start moving things around. Other technologies, Kubernetes, what an interesting technology to be able to containerize. Now we may not be able to containerize everything or run our containers and everything, but it certainly makes our development life easier of spinning up new versions, as well as operations life significantly easier of, I know if a container dies, it's going to be spun back up again. Or even better if we're in the cloud where the operations team doesn't even have to go through and operate or maintain that Kubernetes cluster. With all this technology said, it does bring in some complexity because now we're taking a little bit of technology from here. So when you're just starting out, If you are just taking every single technology and trying to implement them, more than likely you're going to fail because you're going to be just spreading yourselves too thin, trying to do too many things. So get really focused initially, get really clear on that business case, what allows you to do that, and then use these technologies as much as possible to facilitate that.
So also with this, I want to touch on culture for a moment because making a change like this might be a really big deal in some companies. Do you have any advice for how to nurture the working relationships between the people on the teams?
Yes, I've seen this firsthand where the relationships are either bordering on toxic or toxic, all the way to, on the other side, symbiotic. And in my opinion, the symbiotic relationship is what we should be going for. A symbiotic is, I use the word symbiotic because that means that one is not more important than the other. In a symbiotic relationship, if one side dies or isn't working, your symbiote dies. Symbiont, I'm not sure what the word is there. But anyway, we want that relationship, and this relationship can be fostered by making sure that there is adequate praise that goes around. For example, if the CEO is talking about that brand new model, well, that brand new model, usually the praise for that brand new model goes to the data scientist, and usually not much praise going to the operations people or the data engineers that facilitated that. So I believe it's up to the management of those data teams to say, let's say the CEO says, I want to call this out, that they should be saying, don't just call out Jane from data science, also call out the data engineering team that facilitated that. Also call out the operations team because they helped that. This symbiotic relationship, going from toxic to this, I actually did an interview that's going to be coming out pretty soon of how they did that, and it takes consistent determination. It takes sitting at the table and hashing out some of your problems. What I found is that the companies with that sort of culture usually started out with a very siloed culture as it was. And one of the biggest differences, I think, between data engineering versus, let's say, other disciplines, is that we're having to take what were usually different pieces of the company and bringing them together and having them work together. Let me give you an example. Usually analytics will be a separate part of the company and never really had to reach across the aisle to the data science or to software engineers. Conversely, software engineers could do their job without ever having to engage with a business person. Shouldn't have done that, mind you, but could do that. And so now we're saying, hey, everybody, not only are you going to have to work together, but you're also going to have to reach out and work with, in a concerted way, other parts of the company. So what we need to do, this is a management thing. Management needs to be, one, watching for this, making sure that the usage or the interactions with those teams is healthy. And it may come down to sometimes it also is a reflection of the two heads of those teams. If you have your data engineering team who doesn't like your data science person, probably going to trickle on down to the rest of the team. So it's important to model that best behavior.
Right. Ben?
So actually, as Jesse was talking there, I was reminded of a report that Jenn and I are compiling around business, called Business at the Speed of AI, which is a series of interviews. So in this report, we interviewed a few business leaders. And so a few things in that report that are pertinent to what Jesse just said. So first, around tools, it seems like the working assumption of people is that data products, AI, will involve people from many different backgrounds and teams. So you've got business, you've got data science, you've got data engineering, ops, and so on and so forth. So then people are starting to say, well, maybe we should have a platform, a data platform or an ML platform where people can go in and work across these functional teams, with each other within their own team, but also when they're done, they can pass it on to the next team inside this platform. So it seems like more and more companies are either uh, licensing a data platform or going to a software as a service or using one of these open source uh, data platforms from the tech companies and kind of copying them internally. Number two, one of the things that came out of our upcoming compilation is this notion of giving people a path, a career path inside even their own company, right? So one of the people we spoke with led the data science and data engineering at Rakuten, and he was describing a role that they labeled Jesse internally the data wrangler. Well, the data wrangler is basically an analyst who does kind of both some data prep, some data quality, and then also model checking after the model is done. And then over time, the data wrangler in their team, they've come to learn, aspires to be a data scientist, and they've had several examples of data wranglers that have acquired enough skills to transition over to the data science team. And then finally, another trend that seems to be emerging is the recognition that you need to probably have data scientists do more than models. So more than one person we spoke with for this report described data scientists in their company owning pipelines. Now, I'm not sure if that's a great idea necessarily, given if it's production level code, uh, whether you want to do that. But to the extent that you can empower data scientists to write their own pipelines and maintain their own pipelines, that's a win for an organization. So three things there. So the idea that you need some kind of platform where people can work together. Kind of the ability for someone to, if they so desire, to improve their skills and move up the organization to transition to another role. And then three, having data scientists own more of the end-to-end process.
One thing Ben just reminded me of is Part and I talk in the book about dealing with HR. So this will actually be a manifestation, especially in the enterprises, of establishing these new titles. So management should realize this. For example, if you decide to have a data wrangler as a title, you'll have to go through this labyrinthian thing, or usually what companies are having to deal with. Usually they have data scientists, but usually they have trouble with understanding why a data engineer is not a software engineer or a DBA SQL developer, something like that. And I think it's important for you to have a separate title for data scientists and data engineers, not because of specsmanship and what you put on your resume. It often comes down to pay, where companies are consistently losing out on really good people because they're trying to offer a specialist or a sub specialist, is what I've come to term them as, a non-specialist or only a single specialist job. For example, if you try to say, I'm going to pay a data engineer the same as a software engineer, even on the high end of their band, it's not going to happen. They're looking at other deals and offers from people who actually have a data engineer title and a data engineer pay band, which is higher than a software engineer's. So similar for data scientists. They'll usually have their master's PhD. They have to pay for those student loans. They're looking for a pay that is going to help them, one, pay off that student loan, and two, that it was worth it to do this sub specialization that they had to do. Sometimes it can be difficult for HR to really bring that. So I have an entire section. It's not just written for HR, but it's kind of help for HR people.
Another thing we've been talking about on our team, kind of related to that, is responsible AI, and how achieving that requires a company to act to set up teams and that responsible AI and responsible machine learning is a team sport. It has to be involving everybody. So how do data teams fit in to responsible AI, and where does the responsibility for responsible AI fall?
I think the responsibility falls on all members of the data teams. I think it's our responsibility to be calling out when it's unethical to use the data, or when data our usage of data crosses a line. But the issue is when it's everybody's job, it's nobody's job. So I would have to say, my experience, it's definitely the data scientists who are usually the ones that are the most passionate about this. Your data engineers may or may not be, and probably your least likely are your operations people. So I would be looking for the data scientists. I would also be looking for the management. I think management bears a significant part of this responsibility, because it's usually a mandate from the business or from the top that's a top down of something that may be unethical. So I think it's the data scientists and the management, the frontline management there, to do that pushback, because they're the closest to saying, hey, while you're asking for this, it may not be the most ethical thing. Maybe this is a different way we can do that. And I would be loath to put my individual contributors in that tricky situation of telling the CEO we can't do that. I think it's in concert with the data scientists and the management to really do that pushback, so that they know that their manager has their back and that there's a unified front there.
Ben?
Yeah, so this is a case, Jen, where I think a lot of companies are still trying to understand what needs to be done. So I think it's important for people to realize that while we talk a lot about machine learning and AI, the reality is a lot of companies are still very much in the early stages of adoption. Now, with that said, I think there's enough headline grabbing stories that people realize that they need to protect themselves and mitigate some of the risks involved in deploying machine learning and AI. Now, to that end, a little bit of a commercial here. We are having a virtual event on December 15th around this topic, where the focus will be on how you can get started and do something concrete right away. So you can go to gradient-flow.com/responsibleai2020 for details. But at a high level, I think that there's several topics involved here. So there's safety and reliability. Obviously, you don't want to deploy a model unless you test it out and make sure it's safe and reliable. There's privacy and security. So I would say these two topics, I think there's a lot more tools and rigor. And then you've got other topics as well that people understand are important, but there's still emerging consensus and emerging tools in the following areas. So there's fairness, accountability, interpretability, and basically overall ethics and morality, right? So, but these are big topics that people are now starting to grapple with. And, as I list out the topics, it should be clear to the listening audience that this is well beyond technical teams, right? So you need to have lawyers and compliance people, maybe even social scientists on your team, designers, to make sure that you are deploying these machine learning and AI products responsibly and safely.
Related to that representation, we have two new titles, or the importance of C-level representation, I think, for data teams is crucial here, not just for responsible AI, but for everything, but critically. So the reason I say that is, if we have a chief analytics officer with board level representation, or we have a chief data officer, two very good titles, it becomes a conversation amongst peers rather than this upward push. And I think this will really help out companies with their responsible AI.
Well, and the fact that we're in the very early stages of implementation is also an opportunity to get it set up right from the get-go, I would think. So do you have any, Jesse, do you have any advice for how teams can be established from the start to better facilitate responsible AI?
We start by having the right representation, the right questions being asked. It's not just one of our issues as software engineers or as data engineers is we're not usually asking the question why or should we. We're thinking, oh wow, this will look really cool. I can do a conference talk out of this, or my friends will really like me. So we start with that. We start to, in our initial conversations, why? Is this right? Is this best for our customer?
Right. Ben?
No, I like what Jesse said in terms of, as much as we want it to be bottoms up, it's also good to have representation at the highest level of the company. But with that said, I think that it's crucial for teams to try to the best of their abilities to make sure that they have members from diverse backgrounds, not just culturally, but also academically and technically. Because think about security, right? So how many data engineers know crypto or whatever security systems that are out there that might be necessary to know in order to deploy something securely in production?
Right. Well, before we let you go, Jesse, what sorts of interesting projects are you seeing going on out there, and what are you working on otherwise?
Lots of cool technology advancements. One thing that we're seeing is the continued push into real time. This is something I think not just management, every data engineer, every data scientist should be keeping an eye on is, do we have a good use case for real time? Do we need real time, maybe training, maybe analytics? And we're getting better and better tools for this. So one of our issues has always been, how do we do real-time stateful systems? This is kind of the holy grail of what we're trying to do. So we're seeing some really interesting things coming out of the Flink project. They're releasing brand new technology. They're improving some of their SQL interfaces where we actually have a viable system to run SQL at scale in real time and have that happen operationally in a good way. We also have advances in the Apache Pulsar community. They're up to, I think, version 2.7 now. And we're seeing some really cool features around that with Pulsar functions, where we're trying to remove, for example, with Pulsar functions, some of that operational onus of the teams having to deal with, where do I run this? How do I run this? How do I keep all this boilerplate code out? This is something that is better done as a Lambda function, if you're familiar with that, like an AWS Lambda function, except it's running in Pulsar. We also have some of the operational issues with tiered storage, with multi-tenancy, those sorts of things being solved better with Pulsar. To help people with their Pulsar adoption, we have Stream Native Cloud coming out, so people can use Pulsar. I just taught a class where in the class we used Pulsar, Stream Native's Pulsar for that, and we didn't have to think about the operational issues of how do I train my operations team. So just that's a general theme that I'm seeing throughout the community or throughout all the startups is they're trying to create their cloud. So what is you have Imply Cloud for Druid, you have obviously Stream Native, as I just mentioned. What does that do for you? And I think this is helpful for management to understand what these clouds do. It takes out the operational onus of how do we stand up that? How do we start this? How do we operate this 24/7? Takes that out of the picture. Doesn't mean you don't need operations people. It means that you need fewer operations people. But what it doesn't do is it doesn't remove the difficulty or the onus on the architects, the data engineers to create these systems. So as we have a discussion about should we use Pulsar, should we do this, we don't have to say, oh man, we're going to have to train up the ops people, and I don't want to be on call or beeper duty forever, stuff like that. But it's still, no matter which cloud we use, the data engineers have to learn that API, and they have to become familiar with how it works and how it works well.
Hey, Ben, what else are you finding interesting?
So, as many people know, I've been following closely the Ray project. So it's interesting for a variety of reasons. So at a high level, I think increasingly companies are needing to build distributed applications. So a lot of that is driven by the rise of machine learning and AI, because you do need to scale out in order to train some of these larger deep learning models. But it turns out, so Ray is interesting for a variety of reasons. One, it's a C++ open source project with a native Python and Java API, so it's accessible to Python people, and that's what people in machine learning use. Secondly, there's a growing ecosystem of open source libraries in data and machine learning that are going to Ray in order to address some of their needs for distributed applications. So this includes the popular NLP libraries like Spacey and Hugging Face, but also libraries for training deep learning models like Horovod and Ludwig and several other libraries. So, and then finally, I think the other interesting thing about Ray that's a little bit underappreciated is, in many ways, it's probably the right substrate to build the general purpose serverless applications. And also just generally distributed applications. So you can actually build long running services like web apps using Ray. And so, yeah, so the Ray project, a lot of interesting things happening. And I think the validation from the popular open source libraries should pique people's interest.
I want to echo on Ray. I'm really interested in it because you kind of reflecting back on that 10 to 30 different technologies. Well, one of the issues there is actually that who's the first class citizen in there? For example, with Spark, you have the JVM as the first class citizen with Python lagging, quasi first class, probably more second class. With the way I'm seeing Ray doing this, we don't have a first class and second class. We have C++ with these language bindings in. So there shouldn't be a point where they're out of phase. We should be seeing a lockstep with that. And I'm really excited to see that, to see the data scientists being able to write good performant code where we're not having to move data between processes and still having the JVM folks be happy, have the Python folks be happy, have them be performant. And I think we'll see this as a real new step.
Well, with that, thank you so much, Jesse. This has been a great conversation.
Thank you for having me. I really appreciate it, Jen. Thanks, Ben, as well.
Go data teams.